For decades, humanity has been staring into the dark ocean of the cosmos, looking for a mirror. We want to find another world, just like ours, a rocky planet orbiting a stable star with vast oceans of liquid water and skies filled with familiar clouds. We want to know that Earth is not a bizarre, one-off accident in a barren universe. And recently, astronomers may have found exactly what we've been looking for. Sitting roughly 150 light years away is a newly discovered candidate that checks almost every single box for a perfect Earth twin. It is rocky. It is slightly larger than our home world. It orbits a sun-like star, and a year on this planet lasts almost exactly as long as a year here on Earth. It sounds like a paradise waiting to be explored, but the universe has a wicked sense of humor. This promising new world, designated HD 137010b, is hiding a dark, paralyzing secret. If you were to step foot on its surface today, you might not find a lush, alien Eden. Instead, you might find yourself standing in a frozen, silent graveyard, a world potentially colder than the most brutal winters on Mars. The search for a true Earth 2.0 is not just about finding a planet of the right size. It is a delicate, almost impossible balancing act of cosmic physics. To understand why HD 137010b is simultaneously the most exciting and the most terrifying exoplanet candidate we've found recently, we have to look at the incredibly narrow margins of survival in deep space. Let's start with the good news. What makes HD 137010b so incredibly rare is its neighborhood. Most of the thousands of exoplanets we have discovered so far are tightly packed around their host stars. They whip around their suns in a matter of days or weeks, completely baked by stellar radiation. But HD 137010b is different. It sits near the outer edge of its star's habitable zone. You've probably heard this called the Goldilocks zone. It's the specific ring of space around a star where the temperature is just right. Not so hot that oceans boil away into space, and not so cold that they freeze into solid ice. Finding a rocky planet in this zone, orbiting a stable G-type star similar to our own sun, is the holy grail of astronomy. But hanging out on the outer edge of the Goldilocks zone comes with severe risks. This brings us to the massive catch. While the star it orbits is similar to our sun, it is slightly dimmer and quieter. Because of its distance from this star, HD 137010b receives less than one-third of the heat and sunlight that Earth enjoys. Without a specialized atmosphere to protect it, scientists estimate that the surface temperatures on this planet could plummet to a staggering negative 90 degrees Fahrenheit. That is an instant bone-chilling freeze. Mars, our own frozen planetary neighbor, has an average surface temperature of around negative 85 degrees Fahrenheit. This means our supposed Earth twin might actually be a colder, harsher wasteland than the red planet. But there is a lifeline. A planet is not defined solely by its distance from a star. It is defined by the blanket of gas that wraps around it. If HD 137010b possesses a thick, dense atmosphere, specifically one heavily saturated with carbon dioxide, that atmosphere could act like a massive planetary thermal blanket. A strong greenhouse effect would trap whatever faint starlight reaches the surface, preventing the heat from bouncing back into the void of space. If it has this atmospheric winter coat, the ice could melt. Hidden beneath a suffocatingly thick sky, there could be massive churning oceans of liquid water. Right now, computer models suggest there is roughly a 40 to 51% chance that this planet truly lies within the habitable zone. It is quite literally a cosmic coin toss. Heads, it is a hidden ocean world with the potential for life. Tails, it is a sterile, frozen desert. So how do we find out which side of the coin landed face up? This is where the agony of modern astronomy comes in. Currently, HD 137010b is not even officially classified as a confirmed planet. It is merely a candidate. This is because of how we detect these distant worlds. We don't actually see the planet itself, and we see its shadow. Using a technique called the transit method, telescopes stare at a star and wait for a tiny, barely perceptible dip in its brightness. That dimming occurs when a planet passes directly between the star and our telescopes. This candidate was spotted during the K2 mission of NASA's Kepler Space Telescope. The telescope caught a single 10-hour mini eclipse. By analyzing how much the light dimmed and how long the eclipse lasted, astronomers could calculate the planet's size and its roughly 1-year orbit. But in the strict world of science, seeing it once is not enough. A star might dim for other reasons: a passing comet, a stellar glitch, or a completely different cosmic phenomenon. To prove a planet exists, astronomers need to see that shadow cross the star multiple times, right on schedule. Because this planet takes about a full Earth year to complete one orbit, we only get one chance a year to catch it. If a telescope happens to be looking at a different patch of sky on transit day, we miss it, and we have to wait another entire year for the next fleeting glimpse. We are currently waiting for next-generation observatories and ongoing missions, like the transiting exoplanet survey satellite, and to catch this elusive world in the act again. While we wait to solve the icy mystery of HD 137010b, it's worth remembering that it is not the only world competing for the title of Earth's successor. The universe is incredibly diverse, and the other leading candidates show us just how many ways a planet can go wrong or right. Take Gliese 667cc, for example. Located a mere 22 light-years away, it is practically right next door in galactic terms. It's a super-Earth much heavier than our world, and it sits squarely in the habitable zone, but it orbits a red dwarf star every 28 days. Red dwarfs are notorious for their violent, unpredictable behavior. They frequently erupt with massive stellar flares. Any life trying to gain a foothold on Gliese 667cc would have to survive being constantly blasted by deadly radiation from its volatile sun. Then there is Kepler 22b, located 600 light-years away. It is significantly larger than Earth and orbits its sun-like star in a comfortable 290 days. Nay, but its massive size leaves us with a critical unknown: its composition. We have no idea if it's a rocky world we could stand on, a swirling ball of toxic gas, or a massive, endless ocean with no landmass in sight. If we look at Kepler 69c, sitting 2,700 light-years away, we find a terrifying cautionary tale. Its position in its solar system is remarkably similar to where Venus sits in ours. And Venus is the ultimate warning of what happens when a planetary atmosphere goes rogue. Even Venus might have once been a habitable, watery world like Earth. But a runaway greenhouse effect completely broke the planet. Today, its atmosphere is 96% carbon dioxide. The trapped heat pushes surface temperatures to nearly 900 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is so crushing it would instantly crumple a nuclear submarine, and the skies constantly rain corrosive sulfuric acid. While Kepler 69c's star is a bit cooler, potentially making it more hospitable than Venus, the threat of a runaway greenhouse effect looms over any planet sitting too close to its sun. But we also have reasons to be optimistic. In 2023, astronomers discovered TOI 733b, a fascinating world 245 light-years away. Current data suggests this planet might be completely covered in a vast global ocean. It represents a totally different kind of habitability, a world without continents, ruled entirely by deep alien waters. Finding a truly habitable world is an excruciatingly complex puzzle. It requires the right size, the right star, the right distance, and the perfect atmospheric chemistry. It is a chaotic recipe, and if you change just one ingredient, a paradise instantly becomes a pressure cooker or a frozen tomb. HD 137010b may not be the guaranteed backup Earth we are desperately searching for just yet, but the fact that it exists at all, the fact that it checks so many of those elusive, highly specific Earth-like boxes, proves that worlds like ours are out there, hiding in the dark, waiting to be illuminated. It forces us to keep looking, keep measuring, and keep waiting for the data that will finally answer our oldest question: are we alone? If you want to keep exploring the deepest mysteries of the universe and stay updated on the latest discoveries at the edge of space, hit that subscribe button down below. Always leave a comment and let me know, do you think HD 137010b is a frozen wasteland, or is there a vast ocean hiding beneath the ice? Thanks for watching, and keep your eyes on the stars.